Hey everyone, and welcome to another Into the Terminal. Today, we're going to talk about System D because I hear everyone hates System D.
I've heard, and I said I was going to dig out the shirt, and I forgot.
The Everyone Loves System D shirt.
Yeah, I have a shirt. It says "Everyone loves System D" from that time we had Ben Briard on RHEL Presents. He sent us
Right
shirts.
on, right on. Um, the reality is, like, almost every Linux distribution now uses System D. So how hated could it really be when everyone has, not everyone, but almost everyone has pretty much used it as their init system
But is
replacement?
it because they wanted to, Scott, or is it because they were forced by the System D mafia?
I mean, that's like some Bigfoot stuff right there, Nate. Like shooter on the grassy knoll. Like, wow, there's a lot of conspiracy theories that we could throw at
Listen,
that one.
in today's world, there's no reason that my thoughts can't be facts, just like everyone else's. But I digress.
Yeah. So let me first set the stage with why System D. One of the big things that System D brings us is the ability to do parallelization, parallelization
It's a tough
of
word.
systems. It is of system startup. So in the olden days, and we'll actually see one of these in the deeper dive. Um, when you started your system, you identified what services need to be started, and they were executed serially in order. And that meant that like the next thing couldn't start until the previous thing had finished. You could do some stuff like background your thing so that it would kick off and the init system would think that it was done. In reality, it was like still cranking away in the back end. But then you got into a lot of fun race condition things where you had to make sure that it was actually done before some other things that might require it later on in the boot process were starting out. So System D like solves that problem, I think, very elegantly, where in your System D unit definition, you can say, what does this service need? And then System D looks at those needs and the needs of those things and can essentially build a dependency tree of what we need for different services. But if your additional service is outside that tree, it could just be kicked off in parallel, right? Rather than having to be kicked off sequentially because this other more substantial service requires um, additional configuration or system services available for it to operate correctly. And so what this led to is much shorter boot times for Linux systems. And that was like the main
Absolutely.
crux of System D. So much so that we're doing some stuff for RHEL 10.1 now. And one of the features, um, I saw a demo of it in the secret Red Hat space, um, where we essentially rebooted a system in about 3 seconds, which is like, dang, that's awesome. So
Yeah,
I
pretty
look
cool
forward to
stuff.
seeing that in 10.1 and Nate's 10.1 feature announcement that he'll do when we release it in soonish.
It's gonna change your image mode world.
Yeah.
That feature.
Um, but to like dig in on this, why don't we jump into the terminal and I'll show you some of the tools that you can use to actually
Yeah,
see this in action.
this is the critical path, Scott. We're not supposed to be talking. We're supposed to be demoing. Let's go.
Yeah, fine. All right. So if you want to see how long your system is taking to boot, you can use systemd analyze, blame, which is a very entertaining name to have on this function. But essentially, what it does is it goes through and shows you how much time each of the items on your machine took to become active. And so imagine if this was actually a serial based boot time, right? So what we see at the top there is the total time to boot the system was a minute and 59-ish seconds. So let's call it 2 minutes. And then it goes through and it's like 7 seconds was the Google Startup Services. 6 seconds is activating this disk device. 6 seconds is activating another disk device. And so you just kind of can scroll down and see all the things that were part of your startup and how long it took. So you can actually go down and see all of the stuff that was started on your machine. Now, the reality is if you took all these numbers and you added them up, it would be more than the 2 minutes, because this includes all the jobs that start in parallel. So if you're interested in things that were required to get you to your booted system and the chain of events that happen there, there's another systemd analyze called critical chain. And so in order to get to multi-user target from boot took 24 seconds. And these were the requirements that had to be met before we could call it good at the multi-user target and ready to go. And so SSHD was required, and that took 18 seconds to start. And then all the stuff below that was less than 18 seconds. So what we're looking at is the like chain of events that had to happen in order for us to reach the state where we could log in and use the machine. This is a cloud system, which is why it doesn't have a lot and is requires SSHD to access. But notice that what's not in here is like my web server and like all these other components, because that wasn't required in order to get me to a point where I could log into the box. Right? SSHD was required to get me to the point to be able to log in and access the box. So there's still a whole bunch of stuff that happened. That's what the systemd analyze blame does, is it shows you all the different services that were started by systemd and how much time each one of them took. If you're having slow boot times, this is also the tools that you would use to determine who's making your boot slow. Because then you can focus some of your efforts on like, why is this service or these 3 services taking so much time and is impacting my boot time. But yeah, like this is like 24 seconds to get to a accessible system, pretty solid. And it's certainly not the case 12 years ago with RHEL 6,
right,
before we added systemd.
Yeah, as soon as you started adding in services that took longer than a couple seconds to load, I mean, pre-systemd services or servers could take 5, maybe 10.
10
might be the longer end minutes to start
especially up. On premises where you had like the enterprise hardware.
Oh,
and
yeah.
the BIOS and
It's like
system checks done by the
RAID
enterprise
control
hardware.
had to come up and scan all the disks and reassemble the RAID array. And
yeah. So like a 10-minute boot time was very much in target for like my experience in those days.
Right.
And so maybe 4 minutes of that was the Linux boot, right? And another 5 to 7 minutes was the hardware posting and checking and whatnot. But 4 minutes is still a really long time compared to 24 and a half seconds.
Or 3 seconds.
Or 3 seconds, like we were talking about earlier.
But there's another cool sort of sub feature of that systemd analyze, and I'm going to switch screen shares here to show it to you. You can actually have it plot out the output there on a graphic. So check this thing out. Hold on, there we go. Got to see our smiling faces. So this is the systemd. Let's see, systemd. I jotted it down here in the notes here. Systemd analyze plot, and then you redirect it to a file name, and the file type is an SVG, right? So that's a vector graphics image type. But what it gives you is something like this. Now, this is just like one of my test RHEL systems I have running that doesn't really do a whole lot. I had a system that apparently a service had hung at boot and it had been up for a very long time, but the service never finished starting. So I used that as a test machine to generate one of these, and the file was so enormous I couldn't open it in anything. So I had to take a fresh system and to try it there. So your mileage may vary. Maybe look at the text version if if you have a system that's really experiencing terrible problems. But I just thought this was actually really cool because it gives you this graph that shows you the time across the top, right? You see this system only took 19 seconds to boot, apparently. Pretty cool, right? Again, virtual machine didn't have to wait on hardware to come up, didn't have to wait on cloud services. It just booted, right? And every single thing that comes up has its own line graph as to how long that particular thing took. And as you get further down, you'll see that, down toward the bottom, we'll have services that fill up, all the way to the end. And this whole tree setup here is that dependency that Scott was talking about, right? So these services were dependent on um, the the service above it, right? So it's a nice little depiction of what started when, what dependencies were in the tree. I just thought it was really neat, and I'd never seen it before. I learned about it while I was looking at some of the options for System D for this episode. So, like usual, every week, whatever our topic is, I seem to learn something about it. So now you can generate an SVG file. Just maybe on a longer running system, that's a bad idea.
Well, it's because you had one line that was
Yeah.
forever long.
Yeah. Well, no, yeah, there was a service. I think it was the PM logger service for whatever reason on that machine. Last time I booted it, which is weeks ago, it hung at boot and never finished starting. Which
Well, what
meant
was
the
great
system
is
D boot service, like it never reached its final target, but the system's up and running, and I didn't know that. So yeah,
exactly.
apparently weeks and weeks of time were in that graph, and it would have been too large to show on screen anyway. So
Yeah, and that's the other thing is like, because we're starting in parallel, things like SSHD can be running while other things, and you can access the
yeah,
machine while other things are
right.
still starting up.
Right.
Right.
Right. If now
Anyway,
if I had been a better admin about it and paid attention to my system, that probably wouldn't have happened. I would have known that service
I
was hung.
mean, why would you pay attention to things, Nate? That seems very unlike you.
I know.
Um,
I know. Right. Right.
so we have a super serious sponsor this week.
Oh yeah, yeah. We're
Man,
moving up. We're
that's
moving up
right.
in the world.
We have a collab. So we are collaborating with Smoothie Surf, a not very well known, because there's only one location, run out of a canteen on a container ship in the middle of the Pacific. But they offer smoothies on this container ship. And so we tried to get the other smoothie place, but they said we weren't royal enough. So we got Smoothie Surf. You can get a Into the Terminal taro and terminals flavored smoothie. That's right.
Taro. What's that?
Yeah. Well, I mean, it's a root vegetable. And
Oh.
that's because the tagline for our new smoothie is "Taste the rooty goodness."
Oh, right. That makes perfect sense. I bet it's really
Right.
tasty too, and probably healthy.
Healthy, yes. Tasty, probably not. Unless they're adding all that other stuff to it to make it tasty. But anyway, so you can get your own root vegetable flavored smoothie and you show it to your friends and say, "I've drunk the rooty goodness,"
We've
as
got
you
root
administer
in
your
a cup.
systems. There you go. All right. So, and each smoothie is only $1 million.
$1 million smoothie, man. That's awesome.
I mean, you're already flying to the middle Pacific to obtain one from a container ship. I mean,
Is the container ship running Podman or that other container engine?
who knows? Who knows? All right. So now's the time on the program where if you're watching live, put some questions or whatnot in chat. We'll see what we can do. We have a couple of additional demonstrations to go through. So Nate, what are the things that we should be seeing?
Let's see. I've got a demo lined up for how to make a basic service, right? I even have an old RHEL 6 system that we're going to go look at what init scripts used to look like. So everybody dust off your memory because I'm going to tell you installing a RHEL 6 system brought back memories for me.
Memories or nightmares?
It could be both. I mean, usually the installation process was not the nightmare part.
It's true.
Rescue mode, that would be the nightmare part.
I was thinking about like dealing with storage LUNs. That was always a terrible thing, like fiber channel controllers. Blah.
Yeah, or halfway through the RHEL 6 life cycle where all of a sudden all of my network device names changed. That was inconvenient.
Oh, well, that's because you didn't turn off BIOS dev.
Yes, because I didn't know I had to. That's why. Probably my own fault too, right?
I mean, predictable network naming. It's a thing apparently.
Yeah. All right.
So we'll talk about RHEL 6. Then I've got an example for a service timer. So one of the complaints about System D is that it does all the things. And I would say that, like, okay, It's doing a lot of things. So let's see what it's doing. And one of those things is we don't use cron anymore. Instead, we use systemd timers. And they're fairly straightforward to get set up. And I'll show you an example of setting up a systemd timer.
Cool. So let me switch my screen share here.
Well, before you do that, Nate, let's not forget to mash that like and subscribe button.
Yeah, well, you can remind people of that while I'm switching my screen share. All right. Let me bring up my virtual machine here. Everybody get ready. Get ready for this. Oh, it's just a black screen. Hold on. I got to wake it up. Come on. There we go. There we go. It takes a second. Right. It's old. It's old and tired. Okay. So this is my... Oh, let's... We can't see us. Can't have that. There we go. Everything's smaller now. I'm sorry. Okay. Good old Red Hat Enterprise Linux 6.10 Santiago. So in the RHEL 6 days, because RHEL 7 is when we implemented systemd in RHEL, and previous, right? We used I'm going to butcher the name. Is it sysv init or sys5 init? Whatever. The old init system, init, right? And this was just a series of scripts. If you go to etc init.d, right, they're literally just executable scripts. If I were to run one of these scripts directly and I could give it a command line argument, which would tell it to do something to that service, right? So if I were to let's look in, I don't know, all of these are going to be complicated. Let me look for one.
Let's look at SSHD. SSHD is pretty good.
Yeah. Oh, I don't have Vim installed. This was a very simple install. We have Vi though. Okay. So sorry, no color coding for you guys. So these are literally bash scripts, and most of them that I've ever looked at are a case statement within the bash script. And the different pieces of the case statement would tell it things like, what do I do if I need to start the service? What do I need to do if I need to stop the service, right? And these get to be relatively complicated bash scripts if you have a relatively complicated service, right? So,
and actually what you're scrolling through there, like the first time you start SSHD, you have to create host keys. And so in the start, it's like, oh, do I need keys? Oh, well, I need to go ahead and make them. And we made functions to do that.
So yeah, here's a function for start, right? So if you wanted to start up the SSH daemon, it executes this whole block of code, right? And I think and then there's one for stop. And init itself didn't do a whole lot to handle this stuff for you. It basically, init would call these scripts, right? And it would do the start command for each one at boot time. And then you'd interact with them after this. Here's that case statement I was talking about, right? So here we go. We've got case and then $1, which is the command line argument you've passed along to the thing. And you can see that SSHD has a start, a stop, a restart, a reload, a force reload, a cond restart or try restart, status. And if you didn't code all of these into your init script, you didn't get them, right? So ACTPD, for example, had a reload command that would call Apache CTL to reload, but it wasn't always there. So you had to know how to reload Apache yourself until that was added to the init script, right? So a lot of init scripts are very simplistic. They have a start, a stop, maybe a restart, and that's it, right? But handling where the PID file is saved and all that stuff, you have to write that into these things. It's not a thing that happens automatically. And systemd, when it came along, it incorporated a bunch of that into systemd itself. And we'll show you, I have a really simple example of I'm going to build a service file using just a shell script, that calls just a shell script. And you'll see that I don't have to think about any of this stuff. It just happens, right? Anything you want to show inside of this file or anything?
So I got the pleasure of writing init scripts for services because there were services like JBoss that when we originally acquired JBoss, the company, and got the JBoss application server for middleware, they didn't have an init script. It was literally you unzip and then you like run a command and background it. And that was how they started their service. And so
Yeah.
one of the things I did early on was like I wrote an init script for that and then like sent it to JBoss engineering to include in the JBoss software.
Can you please do this? This is better.
Right, exactly. Because the other facet of this is how you get it started, and we'll take a look at that in a second. But writing one of these, like you're right, tracking the process ID file so that you can do things like reload and it knows what to send the kill hup to because you've got a list of process IDs stored in a file for it to kill -hup. Like you had to know to do all of those things. Otherwise, your init script wouldn't function in the same way as other init scripts, or wouldn't offer all the different niceties that other init scripts did. The other thing is like, look at how much stuff is in here
Yeah.
to control.
I just scrolled back, or I searched backward to the start function just to see kind of what it's doing here, right? And you can see there it's got that logic in there that says generate keys if we don't have them yet. It's got a lock file it has to track. It should be outputting stuff to a PID file. I'm not laying my eyes on that at the moment.
I think that might be in the start when it actually like executes the start command, like it does a PID of or something and puts it in the file.
Sorry, I'm just looking forward here.
There you go. No, I don't see it there either.
Yeah, maybe the process somehow does it for us, but at any rate, the point is it's not always straightforward.
And these were like 100, 200 lines long, depending on how much functionality and what you needed your, different operations like a reload to do or a restart to do. So they were, if you had to make one, it was not a great day for you.
236 lines to start, stop, reload, and whatever SSHD.
Yeah, and I noticed that you didn't have HTTPD on this one.
But, no, like I said, this is a base install. I didn't, and can I even connect this to Red Hat at this point to install things? Probably not. I'd have to like mount the CD.
No, I think you can, but you could also mount the CD. But anyway,
I'd have to go get ELS, and I don't have that.
No, you can use 610. Just whatever end of maintenance bits came with 610 without.
Okay, that's valid.
Anyway,
so let's go ahead and sidetrack. Let's go get this thing registered and.
Yeah, let's not. But the HTTPD script was longer than the SSHD script.
Yeah.
And so I actually just looked at my RHEL 10 system, and the systemd unit for HTTPD is 50 lines. That's 50 lines.
Yeah.
So like, because it includes all these additional functionalities and niceties like tracking PID IDs and other stuff, you can narrow down what you need to put in the unit files for systemd. Oh, and of course the case, like you don't need a case anymore. You just like tell it what to do with different commands.
Right. So, and then if you were just administering this machine and you wanted to interact with a service, you don't have to call the init script directly, although you could. There's a shortcut called service. And it literally passes it along to etc initd sshd and then whatever command line argument you gave it, right? So there's the status. So that became muscle memory for a lot of us,
And I think it still works on RHEL 10.
Yeah, it basically replaces service. It like translates it all into systemd. So yeah.
What happens if you look at etc rc.d rc3.d?
There you go.
Yeah, and so Nate, were you going to talk about this, or you want me to do it?
We can certainly talk about it. You can see the weird naming, right? So these are all symbolic links. If I did an ls-l instead, you'll see that they symbolically link out to the init scripts that I was just showing you, right? But they're inside of this structure. If we go etc rc.d, right? Typing is hard. Okay, so that's really hard to see because of the colors. But
there's a backslash in front of your ls, and that'll make it easier.
That's right. We'll get rid of the color. There we go.
There you go.
So you can see there's init.d, and then there's rc0.d, rc1.d, 2, 3, right? And these are all the different run levels for the init system, the init v or init5. And those would basically dictate, they're sort of like targets today in systemd. But for example, run level 3 was like text only multi-user mode. There was no graphical interface. It brought you right to if you were at the console, it would bring you right to a login prompt, and then you'd be just at text terminal. But I think it was run level 5. Yeah, 5 was graphical, right? And to be honest, I don't remember what the other run levels were. 0 was shut down. 6 was reboot. I have no idea what 4 is, or 2.
So 1 is single user mode.
Right.
2 is multi-user mode without networking.
Right.
4 is like your choice. It's kind of like an admin's, if you want to make your own.
Okay.
Yeah, and then like I said, 5 is graphical login and 6 is reboot. And so it is analogous to targets. One might be asking themselves, Scott, how do you know what these different run level or RC directory numbers mean? And it's kind of like man pages, where like main page section 3 is programming libraries, or man page section 5 is configuration files. These were like literally things you had to know as a systems administrator, which today is like, not needed at all.
Right.
But when we look at one of the directories, so the machine would boot, and it would basically, the init daemon would go into this directory, whatever its target run level setting was, and then it would start executing these scripts to get things either started or stopped to comply with the requirements of run level 3.
Right.
So the K script, or the K symbolic links, these are the services we're going to kill. So when the init daemon was running the K scripts, it would actually execute the RC script that we showed you earlier for like SSHD, but with a stop argument. And then after it finished all the things that need to be killed because they shouldn't be running in run level 3, it would then start doing the starts because those should be running in run level 3. And it would do them in serial, right? So S02 LVM2 monitor would run, and then S05 RDMA would run, and then S08 IP6 tables would run. Oh, S08 IP tables, that would run too, but they're the same number.
Right.
Which meant that in order to figure it out, it looked at the alphabetic ordering. So it's still starting them serially, but if they had the same number, it would be like, oh, well, this is alphabetically smaller, so I'll start that one first.
Yeah.
And so if you had to like put a application in here, like S10 is network, right? So if you were going to put in Apache, you wouldn't want to make sure that it happened after S10, because you know that Apache needs networking to work. So you need to order it appropriately to be after networking somewhere.
Right.
Right. You might also want it after logging, right? So you want it after S12 rsyslog. If you were doing like network file systems for your Apache document root, well, that would mean that has to happen after S25 NetFS, where we were mounting our network file systems. So all of a sudden, you had to very intimately know all the different things so you could pick the right number to assign to your service that you're trying to add. To make this a little bit easier, Red Hat had like there's a comment at the top of the init script that has the suggested number based off of the services that came with RHEL at the time.
Right.
So if you just did a service enable, it would go in there, read that comment, and assign it a start or kill number. But man, like what a morass. And like we said earlier, like it was on you to determine the requirements of your service and get it ordered correctly. Whereas with systemd, you can actually say like, my service requires this other service.
Yeah.
And systemd just figures it out.
We'll touch on that a little bit when we get into that. But that was that tree hierarchy that we saw both in your systemd analyze text output and that graphic that I showed before. But yeah, and we talked about init systems. We talked about init run levels, I should say. If you wanted to switch run level, you'd use just the command init and then a number, right? So if you've ever seen an old school admin, and I still do this to this day, out of habit, like I want to reboot a machine, I type init 6, which tells the system switch to run level 6, which is reboot, right? Or if I want to shut it down, init 0, and down it goes, right? By the way, we're done talking about RHEL 6 because we've gone on too long about it already. So I'm going to shut it down, Scott. I know it's fun to go back memory lane and all. But yeah, there were a whole bunch of sort of archaic and esoteric commands that you had to know in order to work with the older style init systems. So,
and not only commands you had to know like this bank of tribal knowledge of like,
yeah,
what run levels meant and
yeah,
what numbers were appropriate and like, yeah.
there's a reason that Linux was always seen as hard because it kind of was. I mean, it still is in some cases, but it's come a long way, long way. All right, so we talked a whole bunch about the old way. Let me switch my screen share, and then we can talk about the new way, and I'll show you how to make your own service.
While you're doing that, Billy asked us to show a RHEL 4 system, to which I refused.
I don't. Yeah, I mean, maybe I could still go get the RHEL 4 installation media, but
I mean, I have a copy over there on the shelf. I can just go and get it. Oh, but none of my boxes have DVD drives anymore. So,
okay. All right. So what I wanted to show you was how to make a service file. So let me find my notes here, right here. All right. So we talked a bit about, the old init scripts. We talked about some of the benefits of systemd and what it brings along. Some of the sort of complaints that systemd got initially were around things like, why does it do so many things, right? And that's kind of beyond just service control. It also does stuff like network manager is part of systemd, right? So that's controlled by your init system now, which a lot of people had complaints about. Journaling, system journaling, which is essentially how logging happens now. That's part of systemd. Time date, right? Time date CTL, that's actually built into systemd. It lets you do things like set your time zone and whatnot, which traditionally was not part of it. Login CTL, which says like what contexts users can get into when they get logged into the system, which if you start thinking about all these things together, it makes sense that they all get managed by the same thing. But there was a lot of pushback to that. And that's why a lot of people just did not like systemd when it first came to RHEL, or when it first came in general, right, to Linux. But with all that extra complexity comes kind of some simplicity for how you interact with things and how you work with RHEL. So, or I should say, with units. So everything in systemd is a unit, right? I just talked about units. There's timer units, there's service units, there's volume mount units. There's all kinds of different unit types. So we're going to make a service unit. So I'm going to start by just making a completely blank text file here. We're going to call it my service.service.
And Nate, if you look at the end of the terminal playlist archive, you'll see that we actually did a 5 different systemd unit types video a while back. So if you're interested in other types of units, like there you can see what they are and how they work.
I'm going to get us into all kinds of chance for typos here because I'm going to type this out so that we can talk about it while I'm doing it. So description is pretty self-explanatory, right? Description is just, if you look up information about this particular service once it's installed, it'll tell you this description. Now, there's more stuff you can put inside of unit. I think, do dependencies go in there? I didn't put a dependency example in here. They may. We'd have to look into that.
I have one in my timer example, so we can hit it.
Okay. Good, good. And then we have to tell systemd what happens when this unit gets installed. And this is where there's a few things you can do, but what I've included in mine is what run level this should get installed into, right? Or I should say target it should get installed into. And I don't know if these are case sensitive. I think they are. I've always made them case sensitive. Like you notice my capital I in install. I think that's required that way. So, all right. So wanted by, right? And these are, a lot of these things feel like they're a little more plain English than we had in the old init system. Okay. We're going to, and we basically tell it what target, right? We're going to tell it multi user.target. Now, multi-user.target is basically like run level 3. And systemd treats them a little bit differently in my experience. It used to be if you put a thing into run level 3 and then you went to run level 5, it didn't necessarily include everything that was in 3. You'd also have to include those things in 5, right? With systemd, it seems to be more cumulative, right? So if I tell this to do this in multi-user target, right? Then I switched to graphical. I forget. I think it's just called graphical.target, right?
Yeah, that's actually a function of the target definition in systemd. So
Okay.
Graphical target says that it also needs
Include
all
this.
the multi-user target
Okay.
stuff. Yeah.
There we go. Anyway, my point is that it's cumulative that way instead of having to define it in a bowl. So I don't also have to say wanted by graphical.target, right? Because graphical.target sort of includes multi-user target. Okay, so now we actually get to define the service itself, right? So we're going to go service, again, typos, and man, keep hitting shift when I shouldn't. I'm used to curly braces and things. And in here, we're just going to tell it what executable to call. And there's different exec lines you can use. Exec start basically tells it to run the thing, right? Yes, I spelled it right. Okay, good. So in my case, this is a shell script that runs date and we'll run it in a loop, right? So essentially, when you call a service, there's two ways to do this that are common. One would be a one-shot type service, where what it does is it runs the service and then the service terminates. That's good for timers and things that run on cron, or not cron, but systemd timers, or things that should start and exit right away. Maybe there's things that should happen at boot that run and leave, right? That would be a one-shot service. In this, when you don't define a one-shot, it assumes that this is a thing that's supposed to stay running. So if I were to call a shell script that would run and exit, then systemd would think that failed. Even though it exited on an okay exit code, it would still say your service failed because I expected it to stay running, right? In this case, my shell script runs a while loop that does a thing every 5 seconds, right? So we're going to save this. And now all we have to do is you notice how short that was, right? What is that, like 5 or 6 lines of actual text? Yeah, 6 lines. Now we just copy my service into etc systemd. Oh, man. There. Now we copy that in there, and that basically tells systemd, like that's where all the unit files that it cares about, that it knows about, that it should load when the daemon starts up, exist. Now you can do symlinks, and when you, a lot of services you'll find are symlinked into there instead of directly files that are inside of there. There, see, and they're like target, dbus, stuff like that. They're in there as symlinks because they actually exist somewhere outside of that directory structure, and that's fine. You can do it that way. So you could put these service files somewhere else. Okay, now we have to tell.
And actually,
go ahead.
Most of our service files do live somewhere else.
Yep. Yeah, there's like, what is it? Varlib
user lib
User
system
lib.
D system. And
Yeah.
so the idea is that if you are a software producer making software that includes systemd units, when you install your RPM with your software, it would put those units in user lib systemd system.
Right.
But if you're an admin, either making custom units for your system or providing override units that should be used instead of the ones in user lib systemd system, you put them in Etsy. So the Etsy
Right.
is a preferred location. If a unit exists in most places, it'll use the one in Etsy. And if the one in Etsy only has some things, but not all the definitions, like you don't define the service, for example, that you were executing, it'll actually pull those things out of the complementary file in user lib systemd system, which is kind of slick. So you can just put in the unit contents that are overrides for whatever is in the base definition.
Yeah. In fact, if you do a systemd edit on an existing service definition, it will automatically place it inside of that .d sort of additive directory structure, right? So it'll take the existing unit file and then whatever overrides that you defined, and then that's how it'll run the service, right? So that's pretty slick too. Okay, so if we do a daemon reload, this just tells it go and read in any changes that have happened. And if any of you are familiar with things like quadlets, using with Podman, this is exactly how you reload your quadlets too, right? So this might look familiar if you're used to doing that, which quadlets is a whole other thing I would love to talk about with systemd, but we don't have time today. Cool feature, really cool feature of Podman on RHEL. Okay, now that we've reloaded it, we should be able to enable and start our new service. Now, basically enable, and now basically enable says, make this a service that will run in the current target. And now says also start it, right? So I'm gonna call it my service. Now I'm gonna be explicit here and say my service.service. You don't have to include the .service. It'll assume .service. If you don't have a .service definition for my service, it will find whatever does match, right? So if you had a timer, like my service.timer or something, it'll sometimes find that instead. So sometimes it's helpful to be explicit.
So
I see you cringing
that
there.
is, yeah, because that behavior is going to be dictated by the version of systemd that you're using.
Right.
And then some unit types like sockets are not going to be automatically found. And socket is another like often used unit type.
Yeah.
So yeah, if you're doing services, you can drop it. If you're not using services, I would always specify the unit extension.
Yeah. Yeah. Okay, so now that we've enabled it, if we do a systemctl status on my service, we should see that it's up and running. That means I actually didn't make any typos that I missed. So that's pretty cool. On such a short file, I mean, it's still likely that I would have typoed something. Okay, so you can see that the output here, and this is actually one of the other cool things about systemd and its integration with the system journal, is that when I do a status on a service, it doesn't just tell me, yes, it's running, or no, it's not. It gives me some useful information, like what PID file it's running, the name of the service, a bunch of other, kind of useful things here, what file it's loaded from. But it also, at the bottom here, you notice it gives me the most recent log output, right? So in my case, like I said, all this does is run a loop where it runs the date command every couple of seconds. And that's exactly what you're seeing here inside of that output, right? If I did journal CTL, XEU is the command or the flags I like to use when I'm looking at a specific unit, because it goes, what is it? Extended. I forget what E is for. Look it up. And U says to look exactly at this particular unit that I'm about to look at. And you can see there's all of the log output every 5 seconds of the date command, right? Now, if I did, remember I was talking before about that edit command? It shows you what's in the existing service file. right? And then if I were to change something up here, if I were to add something above this edits below this line or below this comment, if I put it somewhere in this block right here, I can override stuff that's in, the lower section there, which I don't really have a good thing to modify. We could change the description, I guess, if we really wanted to, but but yeah, that'll make a separate file that'll override the existing service. Okay, and that's my very simplistic service definition. Did you want to move on to your timers thing?
Yeah, we can do timers thing. Somebody had a good question and I've lost it.
I see the chat is like on fire today. You guys are doing good.
Yeah, it's mostly just us going back and forth about silly things like which one of us is Nate. And today I learned that I have a raspy voice, for example.
Totally raspy.
So, yes.
All those cigars.
Like a lounge singer, apparently.
Maybe it's all the screaming. He's a very shouty manager. You guys don't know that.
The worst.
Manager Scott, he's a force to be reckoned with.
Yes. All right. Well, I've lost it now. I responded in chat, but I was like, oh, I should surface that. And then I promptly forgot.
Then you forgot.
Anyway, let me bring up my screen share. And we can take a look at a timer. So these were things that I was generating for my system, right? So that meant that I wanted to put them in Etsy systemd system. And specifically, I made these two units. I made a service unit and I made a timer unit. So what I wanted to talk about was the timer unit. And basically, that's like on a certain schedule, I want to execute this thing. And for my example, the thing I wanted to execute was what I created in the free service unit. So let's take a quick look at that. So in my unit description, there we go. Once, so it wants a free timer as well. And there's also requires. So once is like a soft requirement. Requires means if it's not there, I can't do anything. Nate was talking about the different types of services. My type is a one-shot, meaning I'm just going to execute this thing. I'm not going to care about whether it finishes or doesn't finish. I'm not going to pay attention to its status, nothing. I'm just going to kick off this executable and call it good. So I'm going to run the free command. Oh, I remember what it was. Somebody asked where standard output goes. And we could see that here as well. So standard output, if it's not redirected, we'll still go to standard output, but in systemd terms, that means that it really gets picked up by journald. So we'll see that, and that's actually what we'll take a look at when we want to see that this is running. All right, and when we install it, like we enable it, it's going to be put into multi-user target. So the at boot time, it'll come on as long as we're going into multi-user target. All right, so that's my very quick service definition. All right, then over here is the timer. So timer, just like all units, has a description and any requirements. So this says if free.service doesn't exist, this timer cannot run. Then I have the timer section. So what are we going to do on our schedule? Well, we're going to execute the free service or hit the free service unit. On calendar, what is the schedule with which we're going to run? And what you see is a bunch of stars, right, which are wildcards. The first three separated by dashes are your day of month, and year. So I could do something like every day in June, but only June, right? Or
because that's when you care about this particular thing, every day in June.
Yep, and only June 2025. After this, it stops being important and it won't run anymore, right? So the wildcards here are for your month, day, month, day, and year. Then this next set, this is your hours, minutes, and seconds. So every hour and every minute in every hour, on the 0th second, this timer is going to execute. So essentially what I've written is every minute we're going to run the free service, which after we looked at the free service is going to run the free command. That's it. So every minute we're going to run the free command. All right, and then I said that any standard output gets redirected into journal.ctl. So what we're going to do is we're going to look at the journal.ctl, and we're going to keep it running for today, and we're going to follow the unit free service journal log. So I'm going to go into the journal log instead of showing you everything that's happening on the entire system. I'm only looking at the things that pertain to the free service happening on the system. All right, so you can see that it's been running every minute, and it's putting in this output. And I'll just go ahead and put in some white space on my terminal. So at the top of the next minute, what we should see, there it is. There's the execution of my free service unit definition. And then at the top of the next minute, we'll see another one come in here, and another one, another one, another one, and we'll just keep going. So that's what we do instead of cron now, is we have systemd managing our scheduling through timers and whatever definition you put on your timer.
Can you use wildcards in, like with cron, you would do */5 for every 5 seconds. Does that work with systemd timers as well?
So I've not tried to do intervals. I've only done like a specific time, like 4 o'clock in the morning. But leaving the the month, the day of month, and the year all stars. So it happens at 4 o'clock in the morning every day.
Yeah.
I've done that, but I have not actually, now I'm thinking about it. It may be something different. But I haven't tried intervals. There's actually a great article, and I'll put it in the description of the episode, and I'll just throw it into chat here. This goes into a lot of detail on how you can define your timer. And so it talks about like putting in specific days of the week, right? Maybe you want it on Sundays instead of by the actual date. So that's what we do there. So yeah, that's a quick and simple how we do timers, right? Timers have a definition. It tells me what service or what other unit to execute, and that's where you put your actual script or whatever you actually want to have happen at that time. And it's good.
Yeah, we're having quite the conversation about how many of us by default are still using cron jobs because it's what we're used to. And basically that those cron jobs are just calling systemd timers anyway, because that's how it works now. And how most of us have to always look up the syntax for the cron
systemd timers.
Yeah. Well, no, the cron time, right? The stars, the 5 or 6 stars, right? I always forget how many stars there should be and which order they're in. Every time. It's been 20, 25 years I've been making cron jobs, and I have to look it up every time.
That's part of the tribal knowledge that you just had to commit to memory, Nate.
Yeah, well, the nice thing was it's easy to look up.
Yeah,
and if you can't figure out what man page it's in, or you look at the right cron tab, you can just Google it. And for years, the top Google search or Google result was the right syntax, and it was really easy to read, and that's how I got by. Okay.
Yeah.
So I think that's all of our demos.
Good, because we're like right at time.
Yeah, I had made up my own demo on timers because I wasn't sure if you were doing it, but it was practically identical to yours. So that's fine. We won't do it twice.
It's better than one demo on timers. 2 demos on timers.
2 demos on timers. Yeah. Right.
So next week, we will have another Into the Terminal. I don't think we know what that's going to be yet, but we will be here, and we'll make an episode.
But there'll be another great sponsor. Maybe it'll be Smoothie Surf again. Maybe they'll stick with us this time.
I don't know. I don't hold out much hope that they will have many sales of their root tasting.
After that glowing review of how awesomely healthy they were.
They are healthy. So, all right, everyone. Well, thank you for joining us. Don't forget to mash that like and subscribe button. Clearly, you love us because you've lasted this long in the episode. And
Talking
we
about
will
a
see you
topic
again.
everybody hates.
That's right. Next week, we'll do another Linux topic. And
On
we'll see
something
you then.
Linuxy. Have a great one, folks.
Bye, everyone.